Oh, hi, I didn't see you there. Today I'd like to introduce you to molecular geometry. Okay, this is the part 1 in the series, which we're going to be exploring the shapes of unique molecules. Okay, so let's begin. First off, we have the bent shape. Now the bent shape is a very simple one to remember because it's the one that H2O carries. This is very important for polarity reasons, which we'll explain in further videos, but H2O is this bent shape, and that bent shape gives its is because of its polarity and the amount of atoms that you have here and their pairs and all that sort of stuff. We won't go into that now. So what you need to remember is that bent shape is in this sort of open triangular kind of shape. So it's sort of like an arrow pointing upwards. And that's the kind of shape that we want to make. Okay, you can tell that it's going to be a bent shape if the central atom, see, like this oxygen, is in group 6. Of course, you can have different combinations of the oxygen or other things in group 6. But as long as the central atom is in group 6, then you can tell that you got the beginnings of it to be a bent shape. The other thing that you need for it to be a bent shape, so it's in 2 parts. One, you need to have a central atom being 6. The second part, you need to have 3 atoms. No more, no less, okay? 3 atoms is going to equal this bent shape with this central atom in group 6. Okay? Secondly, we have linear, which is the most extremely simple one you can get. Just a thing sticking out. So basically it's in a straight line, CO2, very plain and boring. Mostly around the 2-ish region, but we kind of have like an undefined because there's no definite grouping in which we can put it in. It's just sort of splattered more around the 2-ish than the rest. And the number of atoms that this has is around 2 to 3. Okay, so most often than not, when it's around the 2-ish and it's got 2 or 3 atoms, then it's going to be linear. Just as long as it's not 6 as the central atom, with the 2 or 3, it's going to be linear. Alright. Next we have pyramidal, pyramidal. Next we have pyramidal, and this one's basically a pyramid shape. So you can use your imagination a little bit. That looks like a triangular pyramid, and this one is with the central atom being in group 5, and the number of atoms being 4. So this one's pretty simple to remember. An example of this is NCl3, and we can see that the nitrogen is in the groups 5 there, so that's the central atom there. And the second last one we have here is tetrahedral, which is very much like the pyramidal. So it's a hard one to say because it's very much like pyramid, but you have to say it slightly differently because someone made a law about it. Tetrahedral, much like this, except it's got a little bit sticking out, and you can turn that around and it'll always have one bit sticking up. So it's a very fancy shape, very nice. You can see that very presently in methane. That's one of those unique shapes that you can very well tell by methane, and especially you can find that it's going to be tetrahedral if the central atom is in group 4 and it's got 5. So these are the 2 things that if you check it off, so you can say carbon, yes, it's in group 4, and altogether it's got 5 atoms, so that's correct. The last one that we have is triangular planar. Now this one is much like pyramidal, pyramidal, much like pyramidal, except it's like someone sat on it, so it's a bit flat. It's extremely flat, and it's on a plane. So this can be seen when the central atom is in group 3 and the number of atoms is 4. So in this example, boron is in group 3, and together with 3 fluorines it makes 4 atoms. And its shape is always going to be like that when it's in the triangular planar shape. Okay, I have some pop quizzes on the side to test your knowledge that we've newly found. Okay, so we've got magnesium chloride. Okay, so I'll give you 3 seconds to think about that, which group it's going to be in. Alright, give you a little bit of a hint. Magnesium is going to be around there. So Have you got it yet? Very simple, easily. You can look at it and say, oh, straight away, magnesium. It's going to be, there's 3 atoms, so it's going to be around this region here. So 3 atoms, so it's either going to be bent or linear. There are these 2 choices, bent or linear. But it doesn't have, I think,